basically the best quantum computer is in your head, believe it or not. Is in your brain. The only thing is your brain is designed not for abstraction, it's designed to run your body.
Right.
It's designed for a different level of abstraction. Basically, your brain takes in millions and millions of inputs per second and has to calculate them all and then spit something out as what we call reality.
Hmm.
Most of it's automatic. So if you actually harness it and wire it, that's like when they're thinking about putting chips in people's brains, because the best quantum computers are basically in your head. But how do you wire it up to actually solve whatever problems, and what happens to the rest of your body while
What
you're
if it's
doing it?
already wired up? We just don't know how to use it efficiently. Like, unless you're trained, like you don't know how to memorize like 4 or 5 decks of cards unless you're trained. But
Hmm.
someone figured that out. Like that would be a much more efficient use, like using mnemonics, using a peg system, and all the other
Yeah, yeah,
stuff.
yeah. But the thing is, what's going to run your breathing, your heart rate, your sensory system, all that other stuff,
Yeah.
which is like 97% of your body's actually doing. You're actually only working with um, your consciousness is working with what 4 or 5% of your brain, and if you're going to do anything else on top of that, it's less, less than 1/10 of 1% to do that. So basically, um, it wasn't designed to do this. Okay, it's designed to do something else. It's simple things. Things for a computer to do. Simple things like facial recognition, all that stuff, is done by your brain, instantly.
Right.
Okay. Whereas a computer has millions and millions of lines of code just to do that. It have to have millions and millions of experience to know how to do that. But the thing is, you get millions and millions of inputs in nanoseconds that your brain has to process. So basically, you have a quantum computer in your head that does all these calculations. The thing is, how can you wire it up to efficiently to do something else?
It's, when I think about stuff like that, it's like, well,
Mm.
are the computers like in the algorithms that they're using are rudimentary, or are we really that good, or just the technology we have now isn't all that great? It's great
It's
now
it,
because it's
it's
new
it,
to us, but
if it's in its infancy. We got to remember it took a billion years to get for that computer in your head. It took a billion years to create of trial and error, down from a simple single cell organism all the way up to where you are. To where you have trillions of cells all cooperating together. In fact, you got trillions. Your brain is not just the brain in your head; it goes all the way down to your toes. That's your central nervous system. That's one
couldn't you
brain.
say that's an algorithm also? Well, they are evolutionary algorithms, but like back to the video game example, like the very first time
Mm-hmm.
you pick up that controller, you're pretty
Mm-hmm.
awful at it. So
Mm-hmm.
like the very first species, what single celled organisms,
Mm-hmm.
um, they didn't last long, I imagine.
Well, I'm sure that you had a bunch of them that a bunch. Well, they didn't last long, but then you had a lot of them being replicated and a lot of them dying. And then with trial and error, they adapt to their environment. Computers haven't been taught to do that because
Um,
computers don't live. I mean, they're not living. Okay, so in other words, they don't have a living adaptive system. Nobody knows how living adaptive systems work. They don't know that they do, and that they replicate and repair themselves, which is a mystery to us. We have an idea, we have an idea how they do it, but we know that they do it. We haven't figured out how they do it.
I wonder if we had like a evolutionary algorithm that just spits out random data. I wonder how long it would take to end up with a human. Like it would
Mm.
probably have to take
Well, it probably well
probably
the
as
thing is,
long.
probably the random data. The biggest part of the random data is to get the first living organism.
Yeah,
You got
you would have
you
to
got
have some
to get the
measurement of
first
like,
cell, because with first cell, and the first cell, then you're going to get, eventually you're going to get something like a jellyfish, which is a colonial organism of individual bits, right? That's what a jellyfish. That's how I recognize. Okay, that's what a human being actually is. A human being is a jellyfish, but it's a cooperative organism that has each individual bit has a is an individual organism, right? But it's
right.
all wired together as an organism, as one particular colony, and eventually it gets smarter and smarter and smarter, and you get larger cell uh, things, on and on and on until you get to people uh, like us, or even whales, which are even bigger.
Do you think that the mutations are? I don't know if I believe in true random. I just believe that there just is there hasn't been an algorithm to figure it out yet. Um, so, like in terms of evolution, where a new species arises, do you think that is part of the algorithm? I guess I'm asking you if it's by
Uh,
design or if it's
it's
by random.
it's probably an algorithm. Algorithm also is adaptive, right? If
Um,
if say well evolution. If the environment changes, certain species rise up and adapt, certain species die out. They can't adapt,
It
right?
could be, but again, if you spit out like if you're in an environment within a given, let's say that environment is within a certain context, and
Hmm.
another way, and you have an algorithm that spits out, let's say, 20 billion outputs, right? And if
Hmm.
only 10 of them survive,
Hmm.
is that adaptive or is that just random data that just doesn't die off within that context?
Um,
That's why I don't.
if it's random, that probably would happen. You know, that probably would happen. Yeah. If that,
I
but
guess
then
it could be either one since we don't know.
how would they know how to replicate again? That's just what they do, or what?
Well, I mean, if you started from a blank slate and you have like an algorithm that just spits random outputs,
Yeah, but the
um,
thing, yeah, what I'm saying is you get. In other words, something. In other words, a slate has to be created in the first place. That's number one. That's what's first thing you have to get by. It has to be.
right,
Uh, it has to be created in the first place, and then
correct.
random will basically solve for some things, okay, but it doesn't solve for others.
Why not?
Um, if it's something completely random, then you would have to have a if you have to start from energy to matter um, to more complex matter to bigger forms and that kind of stuff, all the
It
way
could
down
be
to
it.
life. Life is one of the last things that actually appear.
It could be like a machine learning algorithm that keeps track of the algorithms
Yeah,
that don't work,
you know.
so would know not to do again. But they try like different algorithms. Just keep flipping on like different algorithms to see what works.
Yeah, well, then that would have to be some kind of intelligent learning algorithm, would it not?
Hmm. Well, when you say intelligent, that
Oh,
implies a certain direction. In
yeah,
my
well, the thing is, if the universe was random, and you see bits and pieces that survive in some environments and not in others, you would see a lot more randomness out in the universe.
unless we're not version number one.
Well, if we're not version number one, then we're no longer random, are we? There's a template that actually came out of
Uh,
it, and we're built on an organized template.
uh, because I'm just thinking like if you like again if you have an algorithm that spits out like 10,000 outputs,
Mm-hmm.
if you only need one that survive, could we
Mm-hmm.
say that one output that survive is intelligent, or if it's based on a template, or if it
How,
is a template?
okay, if it survived, how does it know to replicate itself?
If you spit out, I have no idea.
That's the whole thing. Okay, if it's random and a bit does survive, will how does the bit know to okay, this is the bit that survives. How do I know to replicate myself to make more of me?
Maybe replication is an attribute that it acquired randomly. If someone is going to say that replication is a part of intelligence, or if it's not part of
Mm-hmm.
randomness, I would love to hear that argument because attributes can be acquired
I,
randomly
I mean,
also.
I'm saying, well, it could be. Well, it could be, but can all of them? Okay, you can it can randomness say one bit survives and then replicates just out of randomness,
So
and
you
then if
talking
it
about
so if one bit did survive out of
right,
randomness and replicate itself, how come you don't have the same bit all over the universe?
right. I understand what you're saying.
And
So
then
like
how does it go into further randomness and actually replicate a different particle?
same algorithm, different with machine learning. I don't know. I don't know.
That's what I'm talking about. In other words, it's even the mathematician said it's possible. In fact, the fact that it could be possible, the randomness or the math is so gargantuan.
Yeah.
is basically would bust your noodle, and that's just the first bit, and we're not even talking about the rest of it.
Yeah. Yeah.
And
Yeah.
then there's a time factor, and then after that, after you say if you have you got say you got every object in the universe from randomness, okay?
Right.
It's not a pure randomness. Just all of a sudden, over billions of years or billions of trial and errors, that all these objects show up. Okay, what dictates their motion?
Another algorithm.
Another algorithm. Okay, by random, all of them.
I don't know.
Well, all of them would adopt the same motion and organizing as
You
far as
could do.
orbits,
You can
gravity,
create. Yep.
all that stuff would have just automatically out of just they would all just randomly fall into the same laws.
You could all you need, like if you was to create like and this can be modeled today. They even do it in some universe simulated video games where the computer just spits out like an output and it just goes off and it just creates something new. You may not know what it is.
But
So
it's
just
but it's
because
but it's based on what?
it's based on a certain algorithm
It's
that
based on the
it may have
algorithm.
mutated, or it may have adapted, it may have been created intelligent.
But the algorithm is not random.
How can you say it's not? Well,
And the algorithm is not real. The algorithm has laws built into it.
yes,
It's not random. It's not perfectly random. There's laws built into it.
or the
Okay.
laws may have been emerged from that algorithm.
What I'm saying is, but the baseline laws and principles are built into that algorithm, and the algorithm cannot go outside of those walls.
I
It can
agree with that.
it can build random blocks inside of those walls that but it can't go outside of it.
This is where we get to like the inception part, because you can create self-mutating algorithms, and then you create an algorithm like today and you check back on it like a month from now and it'll be something that you don't even recognize.
You don't recognize.
But I agree with you, it does have to be programmed, but
and it will follow, it has to follow a program. It has to follow a law. It can't be now how the result of the law can't be you can't get all of the prediction. Well, you could if you're smart enough. You could if you have a higher enough intelligence. You actually could predict every particular instance of that particular program. It can be predicted. And then maybe not by you, but it can be predicted.
Well, we're talking about infinity, so
or even close to infinity. Basically, if you build say a human being builds basically a random algorithm, we don't have to worry about infinity. It's not even going to get close to it. There's a parameter where that algorithm will break down, because you have to build a wall and you have to build some kind of structure to it.
What if the algorithm has one law and that one law is it doesn't have a law?
Then there's no structure.
That's what I'm saying. We're getting to inception.
So in other words, you have nothing built on. You can't build anything without structure. What's it gonna build?
We don't know.
In other words, if there's no law, there is no structure, you're gonna get ones and zeros, right?
It creates its own law or whatever. I have no idea.
Okay.
I know where you're going with this, and because if the algorithm has to be programmed, there has to have, and if it's on some sort of processor, it has to have some sort of law. I follow you there.
Yeah.
But at the same time, you could create an algorithm that has absolutely no direction whatsoever.
Yeah.
And whatever happens.
If gravity and heat and or gravity or whatever is the effect or the law or whatever you want to call it, then those are the principles or laws that it's built on, and basically it can spit out whatever it wants to spit out, but all those particular particles or whatever you want to create have to follow those laws.
Has to exist within the laws of
the thing that it came out of.
MGTOW.